All right, sixth graders, I'm going to do a quick lesson for this. This is actually a relatively easy lesson, so it was a good one to do over e-learning. What we're going to talk about today is whether, no, just a second. See if I turn my pencil on. Yeah. So, what's the difference between an expression and an equation, and then whether an equation is true or false? A lot of this stuff you know intuitively, so we'll just show you a couple examples and hopefully it'll make sense. I will try to write on it so you can see what I am doing, though sometimes this causes problems. All right, so let's go do this. So if I ask this question, guys, is this number sentence true? Hopefully you would say, no, Mr. Hayden, 2 plus 2 is 4 and not 5. So this is a false number sentence. Because you can write false ones that do not work. A true number sentence would be 2 plus 2 equals 4. This is true because it is factual. It is how the world actually works. So that's lesson one. That there are number sentences that are false and number sentences that are true. Next. This is the difference between an expression, which we've been working with the last 2 weeks or so, and an equation. Let me show you really the only difference is the fact that an equation tends to have an equal sign or a less than sign. So this says the sum means plus, 4 and 5. So this is written as 4 plus 5. This is an expression because it just says 4 plus 5. There's no equal sign. You're not solving anything. It's not something is. This says the sum of 4 plus 5 is. In math, when you see is, it's almost always an equal sign. So 4 plus 5 equals 9. This is a number, is an equation. This is an expression. So if I use the word expression correctly, it should just be 7 plus 3. Is an expression, or 7 divided by 8 is an expression. But an equation is 8 plus 8 equals 16. This equal sign, sometimes you can have an equation, an inequality that looks like this. We'll talk about that in a couple days. That's an inequality, but it's a type of number sentence. But these are number sentences, equations. This is an expression. All right. Number 3. Oh, here's an example. So the first one, these are all number sentences. The first one is an equation because they are equal to each other. This is an inequality because one is more than the other. 4 times 5 is more than greater than 16. And this is, what do they actually call that? I should know that offhand. What do we call this? It just means it's not true. This basically means that it's still a number sentence that says 4 times 5 does not equal 16. So this is still true because you're saying something true. You're saying that 4 times 5 does not equal 16. We won't do that much today. No, actually we will. So a couple of ideas. What the homework's going to be is 2 things. Whoa, what in the world just happened? The homework's going to be 2 things. One is writing equations to see if they're true or false. That's a big part of it. So the first one, reminder, quotient means divide. Sum means add. Less than, you got your minus. So for this first one, the quotient, and you can always slow this down and rewatch it, guys, if I'm going quickly. But the quotient of 99 and 9, so the 99 divided by 9, is your equal signs 9. So that's the number sentence. They're saying the quotient of 99 and 9 is 9. Is that true or false? That is actually false. And if I move my, move my thing here. Maybe not. Come on, guy. I want to move you. All right, there we go. Finally. Sorry, guys. So the true number statement would be 99 divided by 9 equals 11. That would be your true number statement. So we're just kind of seeing how do we write it, is it true or false, and how do we fix it. 1/3 of, remember we talked about the other day, of usually means multiply. So 1/3 times 36 is, that's your equal sign, is 12. Is that true? Well, we do 36 divided by 3. That does come out to 12. So this is true. So you don't need to write anything there. We already have our true statement. This says 3/8 of. So 3/8 of, that's times the sum is plus 11 plus 5 is 8. Let's see if that's true. I don't know. So 11 plus 5 is 16 times 3/8 is going to be, ooh boy, let's see, 1832, 48 divided by 8, and that is actually going to be 6. So this is false. So you'll want to say 3/8 times 11 plus 5 equals 6. And then finally, this last one, it says 4 more than, okay, 4 plus, more than is plus, the product, that's multiply, 4 more than the product of 9 times 2, ooh, 2 squared. Oh, this is evil, guys. Your homework's actually not this hard. I looked at it before I signed it. Is equals 2 less than the product 7, 8. Okay, so 7 times 8, and then 2 less than that. So then you gotta do all that math to figure out if they are correct. And I don't have space right here without erasing some stuff. So let's erase it. So this is 4 plus the product of 9 times 2 squared equals the product of 7 times 6 minus 2. So 2 squared, remember, is 2 times 2, that's 4. 4 plus that. And this is going to be 36 plus 4. This is going to be 40 on this side. This side is 30, oh, nope, 42 minus 2, 40. Does 40 equal 40, guys? It is true. Good job. So that's part 1. And actually does not get quite this complicated. Part 2 is actually finding an answer. Like they say, hey, which of these, how do we fill in the blank? Well, to make this true, what is 8 minus 6? That is 12. So 5 plus what equals 12? 7. Good job. Over here it says 1/4 of 40. So that's 40 divided by 4. That's 10. So what? 1/2 of what equals 10? A half of what equals 10? So you think through that and you're like, oh, a half of 20. This one right here, it says 3 times 12, that's going to be 36, equals 2 squared times a number. 2 squared is 2 times 2, so it's going to be 4 times a number. 4 times what equals 36? Well, that is 9. So it's just the process of figuring out what number works. You'll have to do some thinking, but they're not trying to trick you. They're just trying to show you that true number sentences are ones that have the right answer. And sometimes, obviously, you can have variables do that. So all of these are number sentences with x's. So this is where some are like, but what is x? Why do we care? When you make an equation where you have an equal sign, now we can solve for x and be like, what does x mean in this case? And on the next screen we'll start that, but like some of you could be like right here. Okay, if this is going to be true, what does x have to be to make this true? Well, x has to be 0.5. Any other meaning of x will make a false statement. Like I can make x equal anything. I can make x 7. But 7 plus 4 is not 5. So you make a lot of false ones, but there's only going to be one correct x. And that's why we use variables, because we want to figure out what the x is. So an example of that is here. They're asking which of these numbers makes a true statement. So let's try one. Let's try 5. So 2 times 5 plus 6 equals 3 times 5 minus 1. Let's see if this is true. This is 10 plus 6. This is 15 minus 1. 16 equals 14. Is that true? No, that is a false statement. So let's try 7. 2 times 7 plus 6 equals 3 times 7 minus 1. That's 14 plus 6 equals 21 minus 1. That's 20 equals 20. That looks true. So this is our true statement. This is wrong. And if we would try this one, it is also wrong. So that's where we're combining true sentences with our variables. We want to find which number makes it true. And then they'll have you try a couple, like in this one, they'll be like, hey, try all these numbers, see which one is right. You'd be like, okay, 2.4 plus 7.4 equals 10. That's going to be 9.8 equals 10. That is incorrect. It does not equal 10. So that one is false. So they might do 2.6 plus 7.4 equals 10. That's 10 equals 10. That's good. They'll do 3.6 plus 7.4 equals 10. That ends up being 11 equals 10. That is not correct. So that is not true. So it's just plugging it in and see, is it right or is it not right? And I think that's basically the lesson, except for one last thing, which is they'll have one like this, where you have to match them. And I want to do this largely because one of these setups is really confusing for no good reason. So let's look at A. There are 15 dogs in the shelter. The number of dogs is 5 times the number of cats. Let X represent the number of cats. So which of these equations over here means that you have X cats, there are 5 times number of dogs and cats, and should equal 15? Well, this one does, because we have the cats times 5 equals our dogs, and that makes sense. Here B, there are 15 fish at a pet store. The number of fish is 5 more than the number of hamsters. So fish is 15. The number of hamsters is X, it says. And it says the number of fish is 5 more than hamsters. We're going to plus 5. That gives us our hamsters. So this one goes here. We said earlier that there's 15 dogs in the shelter. That's 5 times the cats. So that goes here. Okay, C. C is weird, but I'm going to just walk through it. There's 5 birds at a pet store. The number of mice is 15 more than number of birds. Let X represent the number of mice. How you want to do it in your head, how my brain always goes up, because there's 5 birds, okay, and then there's 15 more than that, and that's going to equal X. That doesn't work in this case. So we got to find something where X will end up being 20. And the only one where that makes sense is here. So what they're saying is the number of mice is 15 more than the birds. So if we take the mice and minus the birds, we will get our 15. I don't love how this is phrased, but there's an example. Then D, a bowl has 5 cups of cat food. 15 cats share it evenly. Let X represent how much food each cat gets. So there's 5 cups altogether. There's 15 cats all eating something. And so that's how we get this. 15 cats eating something for the total of the 5 cups of food. Hopefully that will help you out on number, I think it's 12 in your homework. All right. Good luck, guys. Bye.